98% of Saudi Arabia's land is nothing but sand. But in the middle of this seemingly uninhabitable desert, they are creating their own rivers. Massive streams of water are drawn straight from the ocean, crossing scorching deserts and climbing mountains over 10,000 feet high, long enough to wrap around the earth 35 times. Thousands of pumping stations run 24/7, supplying 5 billion gallons of water every day to sustain 35 million people. Keep reading, because you're about to discover how Saudi Arabia created its own lifeline. Did you know Saudi Arabia is one of only 18 countries in the world without a single natural river? Yes, no rivers, no lakes. The high plateau terrain blocks moisture from the sea, so rain clouds can't reach inland. On top of that, the climate is so dry and harsh that temperatures often hit 122 degrees Fahrenheit. On any climate map, Saudi Arabia looks like a place where life shouldn't exist. Each person only gets 68 to 90 cubic meters of water per year, 5 times less than the absolute scarcity threshold set by the United Nations. In comparison, the average American enjoys up to 9,000 cubic meters. The difference is staggering, and as we all know, humans can survive up to 3 weeks without food, but only 2 to 7 days without water. That's why in Saudi Arabia, water is always a matter of life and death. To survive, they had to dig deep into the desert, searching for underground treasures, ancient fossil aquifers that took thousands of years to form. Since the 1980s, thousands of wells have been drilled, pumping up trillions of gallons. In 1992, water consumption reached 7.5 trillion gallons a year, enough to fill more than 27,000 Empire State Buildings. But that joy soon turned into an addiction to wasting fresh water. The harsh truth is that fossil groundwater can't be replaced just like oil from a depleting well. In just 25 years, water levels in the Al Asa aquifer dropped by nearly 500 feet. By 2012, 80% of the 132 trillion gallons of groundwater reserves were gone, forcing Saudi Arabia to launch a survival plan, cut consumption to 40 gallons per person per day, just 1/7 of what Americans use, about 300 gallons per day. Cities installed smart meters and imposed heavy fines for waste, from leaky faucets to watering lawns. In agriculture, thirsty wheat fields were replaced with drip irrigation and moisture sensors, making every drop as precious as gold. In 2015, agriculture alone used 6.5 trillion gallons, but by 2020, nationwide consumption dropped to 4 trillion gallons, a nearly 40% reduction. Still, each Saudi citizen uses about 321 gallons per day, roughly the same as the French. Saving water only bought Saudi Arabia some time, but it couldn't stop the exploding thirst of its growing population and agriculture. Just as America can't simply save gas without developing new energy sources, Saudi Arabia realized they needed a massive, sustainable, and nearly limitless supply. And the only source around them is seawater, which makes up 97% of the world's water, but is salty and undrinkable. Early experiments began in the 1970s, but it wasn't until the early 21st century that tens of billions of dollars in investment turned this plan into real power. If in 2015 total desalination capacity was just 1.6 billion gallons per day, by 2024 Saudi Arabia operates 41 desalination plants along the Red Sea and Persian Gulf, producing around 3 billion gallons of fresh water daily, 22% of the world's total desalination output. To put that in perspective, the entire United States desalination system combined is less than 1/5 of this, even though America's coastline is much longer than Saudi Arabia's. At the heart of this network is the Ras Al Khair mega complex on the Persian Gulf. This plant alone produces 264 million gallons of fresh water daily, enough for nearly 2 million American households, and generates 2,400 megawatts of electricity, equivalent to 2 medium-sized nuclear reactors. Ras Al Khair's pipelines and treatment systems stretch hundreds of miles, operating 24/7 to supply both drinking water and electricity to itself and nearby industrial zones. After building this huge desalination network along the Red Sea and Persian Gulf, Saudi Arabia faced an even trickier challenge: how to turn salty water into fresh water with less electricity, fewer emissions, while demand keeps rising. The race centers on two core technologies. First is multi-stage distillation massive plants using multi-stage flash and multi-effect distillation. The principle sounds simple: heat, evaporate, condense, but the scale is mind-blowing. Imagine hundreds of sealed steel tanks, as long as football fields, where seawater is heated nearly to boiling, then passed through chambers with decreasing pressure, to flash, evaporate at lower temperatures. That vapor is condensed into pure, fresh water. The big advantage of multi-stage flash and multi-effect distillation is durability, 20 to 25 years, and the ability to handle all kinds of feed water without scale buildup. Even leftover steam is reused to spin turbines, offsetting some of the energy cost. In contrast to the heavyweight distillation, there's reverse osmosis, a young but rapidly advancing technology. Based on the biology of human cells, reverse osmosis forces seawater through ultra-thin polymer membranes, just a few millionths of an inch thick. The pores are so tiny that even viruses can't pass, filtering out up to 99% of salt and minerals, producing almost perfectly pure water. The most impressive part is the energy efficiency. Thanks to pressure recovery devices, modern reverse osmosis plants use only about 2.8 kilowatt hours for every 264 gallons, about the same power it takes to light 10 LED bulbs for an hour. Compared to multi-stage flash or multi-effect distillation, which once consumed nearly 9% of the nation's electricity, the difference is staggering. This huge gap in energy costs led Saudi Arabia to switch its entire desalination system to reverse osmosis, while also integrating renewable energy to cut emissions. Today, about 2/3 of urban water demand is met by desalination, meaning every glass of water in Riyadh is tied to reverse osmosis filters, electricity, and solar panels running day and night. Alongside this, the country built over 500 dams nationwide, with a total storage capacity of about 2.2 billion cubic meters. The King Fahd Dam in Wadi Bisha, for example, holds over 325 million cubic meters, making it the largest dam in the country. These reservoirs don't just supply drinking water to millions, they support agriculture in the desert and help recharge the shrinking aquifers. But aside from the water purification process, have you ever wondered what happens to the salt after seawater is filtered? For every liter of pure water produced, up to 1.5 liters of concentrated brine is dumped back into the sea, about 60% of the original intake. In the Red Sea, where many plants are located, dead coral zones and disappearing fish have already been observed. Experts call this the hidden cost of desalination. If discharged directly, the waste raises both temperature and salinity, threatening the entire coastal ecosystem. To prevent disaster, Saudi Arabia is testing deep-sea multi-port diffusers, offshore dispersion technology, and even brine mining to extract salt, magnesium, potassium, and rare metals, turning waste into resources. After solving desalination, Saudi Arabia faced an even bigger challenge. The original water distribution network only prioritized the capital Riyadh and the holy city of Mecca, while many remote communities, even some large cities, still lacked a stable water supply. How do you get billions of gallons of clean water across the desert, up mountains, nearly 10,000 feet high, and into every city and village? The pressure is even greater. As the population explodes, Riyadh had 5.2 million people. In 2010, over 7.8 million by 2024, and is projected to hit 9 million by 2035. To solve this, Saudi Arabia chose enclosed pipelines instead of open canals. This was a smart move. Pipes require less digging, are faster to build, reduce evaporation under the 122 degrees Fahrenheit sun, and keep out sand and contaminants. The result is a gigantic artificial river. The main pipeline system stretches 8,820 miles across desert plains and up to 9,186 feet high, twice the length of the Nile. Including all distribution branches, the total length reaches 880,000 miles, enough to wrap around the Earth many times. No wonder Guinness World Records recognized it as the world's largest water pipeline network. Water from desalination plants is first pre-treated and purified ideally by reverse osmosis, but sometimes by distillation, then post-treated and stored in massive tanks. From there it flows through huge trunk pipes, like the main channel of a river, branching into thousands of smaller lines serving each city and village. Riyadh's storage tanks alone hold nearly 1.3 billion gallons, a world record for roofed capacity. The entire system can deliver up to 5 billion gallons of clean water daily, about as much as the entire state of Texas uses on a peak summer day. Laying hundreds of miles of pipeline is hard enough, but getting them over barren mountain ranges is even tougher. Each segment of pipe hundreds of miles long is a massive challenge, but hauling them over rocky mountains is even harsher. First, there's the enormous energy cost desalination, and pumping alone eat up 9% of the nation's electricity, about as much as 20 million American homes use on a hot summer day. Every gallon of fresh water pumped across the desert means burning more oil. Then there's the brutal desert climate. With temperatures regularly hitting 122 degrees Fahrenheit, any mistake is costly. If open canals were used, billions of gallons would evaporate before reaching people. That's why Saudi Arabia had to build 880,000 miles of enclosed pipes, enough to wrap around the Earth 35 times, to save every drop. Pushing water up 9,186 feet through rock and sand dunes is like building a river that flows uphill. Just one section a few dozen miles long requires thousands of workers, giant drills, and high-pressure pumping stations running non-stop. When the land-based desalination network hit its limits, both in energy and infrastructure, Saudi Arabia realized it needed another escape route for the future. In 2022, the SWCC Corporation, together with private partners, launched the first 3 floating desalination stations, each a mobile desalination plant installed on giant barges anchored off the Red Sea coast. These modular stations can add more vessels to boost capacity anytime and move flexibly along the shore. Each floating station can produce up to 13.2 million gallons of fresh water daily, enough for almost 150,000 American households, an impressive number compared to many coastal United States cities. Unlike fixed concrete plants that take years to build, this model is extremely agile. A giant ship docks, and millions of gallons of clean water are ready to flow into storage tanks and join the national network. When a region no longer needs emergency supply, the floating station simply lifts anchor and moves to another coastal area in need. This is a long-term strategic move. The barges are designed to integrate with renewable energy like solar and offshore wind, helping Saudi Arabia get closer to its net zero 2060 target, aiming to cut about 37 million tons of carbon dioxide, thanks to energy-saving desalination and increasingly green operations. With modular design, they can easily expand the fleet, creating a mobile river along the coast to supplement the massive land-based pipeline network. The significance of this fleet goes far beyond just supplying clean water. It brings water to remote areas without pipelines, creates thousands of high-tech jobs in operations and maintenance, and most importantly, proves that Saudi Arabia isn't just solving today's water crisis, it's shaping the future of the global water industry. What's remarkable is that what Saudi Arabia is doing doesn't stop at its borders. Desalination technology and this pipeline river network could be a global solution to the water crisis. Imagine arid regions like Africa's Sahel, South America's Atacama Desert, or even drought-stricken California, all could use the Saudi model to turn seawater into fresh water and pump it hundreds of miles inland. If coastal countries work together, floating desalination fleets and pipeline rivers could become a global rescue network bringing clean water to hundreds of millions. So what do you think? Could this technology save thirsty places around the world? Will we one day see artificial Niles in America, Africa, or maybe even right where you live? Leave a comment below and share your thoughts so we can discuss together. And don't forget to hit subscribe right here so you don't miss more incredible and surprising stories about how humans are challenging nature to survive.